We've talked a little bit about like terms, and today we're going to define them more clearly and learn how to combine them. So first we're going to make sure we know what we're talking about. Let's talk about some vocabulary. So first is a variable. That's a letter or symbol that represents a number. X, Y, and Z are very common, but we can use T and A, B, and C and all sorts of different kinds. And then an expression. An expression is a collection of numbers and variables with math operations. It also has no equal sign. If it has an equal sign, then it's an equation, not an expression. So like this thing down here as a whole is an expression. It has numbers, has variables, and it has math operations, like the pluses here. It can also have minuses, times, divided, all those things. And the last term is term. Crazy. So a term is a part of an expression. So this expression down here has three parts: 4x, 3, and 7y. So each of those individually is a term. So 4x is a term, 3 is a term, and 7y is a term. So what you will often be asked to do with these things is to simplify them. Simplify means to reduce to a smaller form by regrouping terms of the same variable. So we might start with 4 terms and want to combine like terms so that we get down to 2 terms or 3 terms. Like terms are parts of an expression whose variable patterns are the same. So variable patterns means same variable or variables, it could have more than one. Same variable or variables and the same exponents. So saying the variable patterns are the same means they have the same variable with the same exponent. So over here we see 2 terms, 4x squared and negative 2x squared. Both of them are like terms because they have x as their variable and it is squared. So if they had told us 4x and negative 2x squared, those are not like terms. Because while they do both have an x, this one is raised to the first power, this one is squared. So their exponents are not the same. So those two are not like terms. They don't have the same variable pattern. So you'll often be told to combine like terms or just told to simplify. So as we see, 2x and 5x are like terms. That's why they're circled, because they both have the same variable pattern. They have x, and it's x to the first power in both of them. This term, 4y, has no like terms. There's no other term in this expression that has a y. 3 also has no like term. It's called a constant because it has no variable with it, and there's no other constants in this list of terms. So the only ones we can combine or simplify are these 2 right here, because they're the only 2 like terms we have. So if we have 2 x's and we add 5 more x's to them, we have a total of 7 x's. Now since these 2 had no like terms, we do nothing except just rewrite them just the way they are. So if we were told to simplify or to combine like terms, and we started with this, our ending answer would be this. Okay, 2 more terms and then we'll do some practice on the back of this page. Oh, maybe not. I'll do some practice on another page then. So anyway, a coefficient is one type of number. So numbers appear in expressions in 2 different ways. One of them is a coefficient. That's the number in front of the variable. So like up here in this expression, 2, 5, and we'd call this a -4. We treat the minus as a negative sign. 2, 5, and -4 are coefficients. Down here, 4, 2, and -3 are coefficients. There's also constants. Constants are a number that stand by themselves. They have no variable. So up in this one, 3 was a constant. Down in this one, 1 is a constant. And constants are like terms as well because they don't contain any variables. So constants have the same variable pattern because they have none. If you don't have any variables, and neither does the other guy, you guys have the same variable pattern. All right, give me just a second to grab my sheet with some practice we can do. Okay, let's see. Let's start with number 1. -6k plus 7k. So there's just two terms. These are all expressions. All on this page, they're expressions. This one has just two terms. They are like terms because they both have a k, and it's k to the first. So we can combine these. So we just say -6 plus 7 is +1, and we keep the k. Because we were down 6k's, but then we added 7 of them, so now we're in a +1k. And you don't have to write the one with it, but you're welcome to. So you could write the answer as 1k or just k. Either one of those is fine. Okay, let's jump down to number 12. We have n plus 4 minus 9 minus 5n. So one thing you can do if you want to is try to mark things to show that they're alike. So for example, I would notice that n and 5n, or -5n, are like terms because they both have n. So I might just circle those two to help me remember those two are like terms. So remember, n by itself means 1n. So it helps you to write the 1, do so, but you don't have to. 1n minus 5n is -4n. Because we were up a +1, but then we subtracted 5, so now we're down 4n. Now in the middle here, these two constants are also like terms. Because that has no variable, that has no variable. These are constants, they're like terms. So we have a +4 minus 9, which gives us a -5. So this expression, simplified, is -4n minus 5. Now one reason I wanted to do this example is to make sure you saw that the sign we use is always the one directly in front of the term. So some people understandably would say, okay, there's an n, there's a plus, then there's a 5n. So they want to say n plus 5n. But this doesn't matter for the 5n. This plus only matters for the 4. So it's only the expression, or not the expression, the operation directly in front of the term that matters. So that's why I circled just the n, but I circled the whole minus 5n, because that minus, or if you want to think of it as a negative sign, does apply to the whole thing. Okay, let's try number 21. So this relates us back to our previous lesson, which is the distributive property. So when you see these parentheses, you should do the distributive property first, then try to combine like terms. So I'll just leave the -4 as it is for now. I do 7 times 1, which is 7, minus 7 times 3m, which is 21m. So these two are like terms because they're both constants. -4 plus 7 is +3. And then this is its only like term. I should say, this is the only term with an m, So it has no other like terms. So we just rewrite it just the way it is. Okay, I'll do one more, then we'll close. So we'll do 27. This one requires the distributed property twice. So we'll deal with that first. We have negative 10 times 1, which is negative 10, minus negative 10 times 9x, which is negative 90x. That covers the first distribution. Then 6 times x minus 6 times 10, which is 60. And one habit you really need to get in the rhythm of doing is anytime you see minus a negative, change it to plus a positive. Now, it doesn't matter if you combine these two first and then these two second, or if you want to put the x's first, you can do these two first and these two second. So it's okay either way as far as that's concerned. So I'm just going to do these first because negative 10 comes first in the expression, but it doesn't actually matter. So negative 10 minus 60 gives me negative 70. Because if you do keep change, it'd be negative 10 plus negative 60. So you're adding the same terms, negative 10, negative 60, which means you add them and keep their sign. Then we have 90x plus 6x, which is 96x.